Okay, so recently I was working on a project and I needed multiple voltages, and my uh, benchtop power supply that I've been using only has one output. So I started thinking by myself, maybe this is time to get a one of those linear power supplies. And I had a look at what was available, and actually I saw this thing over here, which is obviously not a linear power supply, but it was cheap. I got it for less than $100. It says $104, but you know, you have sales and various things on AliExpress, and I got it for less than $100 delivered. So I thought, what the heck, I'll buy one of those things and see what I can do with it. And it has uh, multiple outputs, as you can see, and it has serial parallel. Also, uh, not long ago needed a higher voltage than 30 volts, and most of the power supplies that you get that have single outputs and so on, they are 30 volts. But when you can put them in series, like this one here, you can actually get 60 volts out of them, which is what I desire. So we're going to have a look at this thing today and open it up and see what we can find out. But let's have a look what I have currently and what I have been doing, and also what I found out when I was looking for linear supplies on the internet. So first of all, let me have a look here. I saw a review of this Uni-T thing recently, and I kind of liked the looks of it. These kind of things, they have multiple two channels like outputs, and a third one usually like for 5 volts and so on. But then I saw the price here, $369, and I thought, well, you know, that's kind of what you would expect for a high quality linear power supply. But then I noticed that the shipping, in fact, it's been going up and down. It was $365 the other day. Now it is $348. I actually contacted the Uni-T store, and they said, yeah, that's correct. It's heavy, so that's why the shipping is over $300. So that would make it over $700. So then I started to have a look. This is even worse, and this is a sort of a recent development, I think, on AliExpress. This here is a similar device from Siglent, which maybe I might even prefer. I'm not sure, but $631. It will cost a lot more, and they want $436 shipping, so that would make it over $1,000. And I've actually found that locally in the US you can buy one at Jamico for $400, and they want $17 shipping, so that would make it 400 and there'll be some tax on there, 420 or $30 or something. So that's actually a lot cheaper than what you can get on AliExpress. So that's kind of interesting that something has happened. I think the shipping has gone up on the Chinese end. In any case, but still, that's like over $400, and that's why I was thinking by myself, can I make do with a $100 device and save myself $300-400? Because I'm also in the market for a benchtop like 5 or 6.5 digit multimeter, which I would like to get. But they tend to be $400 or $500. I'd rather spend money on that. Anyway, so let's have a look what we can find out about the existing power supplies that I have, and see how they compare. Okay, so this is my little bench power supply. I actually quite like this thing. I think they've discontinued them. I haven't been able to find it anymore, but I particularly like this one because it has everything is on the display. Over voltage protection, over current protection. You can set the voltage and the current, maximum current, and so on. And it shows you everything at once on the display. but it is a switch mode supply. I've never actually put this thing on. This is my electronic load. I've never actually put it on the load to see what the output is like, but I have never ever had any problems with it. So it's quite a good little unit. But as I said, sometimes I need multiple voltages, and sometimes I need more than 30 volts. This is a 30 volt, 10 amp power supply, and so some of the things that you'll be looking for if you're getting a power supply, this particular one has a button to turn it on, but it also has a separate little button to actually turn on the output, which is important, I think, because sometimes you need to make adjustments and so on. So you can turn the output off, then you can make some adjustments here, and just in case you fudge up or do something wrong or something and accidentally choose to a higher voltage or something, it doesn't matter because it's not connected to the output. Some of the other power supplies, and in fact the one that I got that I showed you earlier, I thought it had a switch like that for power, but it's actually an on-off switch, which is not such a good thing. And in future I'm going to have a look if I can do something about that myself, put some external switches on there or something. But in any case, also this power supply, this is the ground, is not connected to ground, but there is a ground pin over here, so you can actually connect those together. And what I've been doing in the past is when I had needed multiple voltages, I made up this little thing here with a little switch mode. You'll see those on AliExpress, and it has a display on there fairly similar to what most power supplies have, you know, current, amps and watts and what have you, I think. I will plug that in, like if I need 5 volts and 3.3 volts, I was actually setting the main supply to 5 volts and plugging this thing in, and then setting it to 3.3 volts, and I'd have a separate 3.3 volt output. But it's a bit kludgy doing that, and that's why I said if I need multiple voltages, I would rather have a power supply, and also sometimes I need more than 30 volts. So as I said earlier, and these things of course cannot supply more voltage than what you put in. Okay, so this is the thing here. It's quite deep, nice power, it says. In any case, when I saw it on the listing, I was thinking that this switch here would be the switch to actually switch the output on and off, and it might have a switch on the back or something for the actual power, but it's not. It's the actual power button, which is unfortunate. And I will be looking at that sort of thing at some time in the future to see if I can. I want this switch just to switch the power, but I want the display and everything to stay on. So I'm going to have a look inside. I haven't looked inside yet. We're going to be looking at it together. In any case, so far I've just got the multimeter connected to it, and you can see up the top there what the voltage is. It's set to 25 volts and it's outputting 25.04 volts. And of course you can select the amperage. And for some reason it's supposed to be able to do 30 volts, I thought, but oh yeah, it'll go up. 31 volts. Looks like it is 0.04 volts out, but you know, that's next to nothing. 40 millivolts. Yeah. There's 2 voltage and current controls. So when you hit the little buttons, you can actually, if you hit it again, you can actually select the digits. Okay, fair enough. So right now it is set to so-called independent, and this is the channel A, and that's the channel B or something like that. And if I look for voltage on the other channel, there's nothing there, even though it says 25 volts on the display here. And this one here is actually supposed to be the output when you select serial or parallel. So let's have a look. If I select something here, there you go. So that's interesting. The two ground points over here are actually independent. You see that? If I left it plugged in here, I get nothing. But if I plug it in here now, I have 25 volts on this output, which is actually a good thing, because sometimes you might have a need for two completely independent outputs. So anyway, so right now let's set it to parallel, and the display here went off because now we only got one output, and for some reason it went to 31 volts, and now the output is supposed to be coming out of this socket here, and indeed we got 31 volts, and 10 volts, and so now we are supposed to be able to get up to 20 amps, I believe, because it's in parallel. Yep, 20 amps. I'm not drawing any current or anything right now. I'm just having a look at the display. So it has here constant voltage, constant current, and I am not sure if there is any way to tell it what you want to do. Like my main power supply there has over voltage and over current protection, but I guess that once, if it tries to draw more than whatever you got the current set to, it will actually go to constant current mode, and it'll reduce the voltage, and that little light will probably come on. That's probably how it works. Now, what happens if I go serial? We still have 31 volts, but actually it went to 61. And yep, we got 61 volts. But now the current, it says it can go up to 10 amps. But I thought the documentation said that you can only get 5 amps at 61 volts, but it seems to be able to set it to 10 amps. Anyway, it also has a 5 volt output here on the USB port. So anyway, so far so good. Now let's hook it up to our electronic load and the oscilloscope and see what the output looks like. Okay, so actually before we get hooking this thing up, I thought I would discuss the leads. These are the leads that came with it, and I was pleased to see that they have proper solid plugs on them. You know, they're the ones with little slits in them. And my other power supply came with really crappy leads, and it had these kind of plugs on them. These are total junk. They actually swivel around, but they make terrible contact. And don't forget that these power supplies, this one can generate up to 20 amps. If you're going to put 20 amps through a lead with a high resistance, you're going to get a voltage drop, and potentially even it could melt something or something in the wires as well. So that's why when I get a power supply, I normally buy these kind of plugs, and these are similar. You see, they've got those. They're solid brass, and they have little slits in them. You can open them up to make a good contact. So let's have a look at the resistance of these things. I'm going to use this milliohm meter here, and these are the leads that came with it. And we are talking 37 milliohms roughly. Now, the leads that I have made up myself with those plugs I showed you earlier and some good wire. These are, see, it has plugs on there, and I put these kind of clips on there instead of those crocodile clips, which are not much good. And if I measured my clips that I made up, I have, this one is 20 milliohms instead of 37, roughly half. And where's the other one? Oh, here. 19.4. So it's about 19 to 20 milliohms, so it's roughly half. So my leads that I made up are still better, but nevertheless, the ones that they put with the power supply are a lot better than what I normally been getting from other Chinese suppliers. So to give you an indication, if you are drawing at 20 amps and your lead is 0.037 ohms, you are dropping 0.74 volts at in your lead. And if it is at 30 volts, you're actually dropping 22 watts through your lead. So that's why when you're talking about high power supplies, you got to take a note of those things. And you might see, if you hook a electronic load up to it and draw 10 amps or something like that, you will probably see that the electronic load sees a lower voltage than what your power supply is outputting. Okay, so I have the power supply connected to the electronic load. I've got it set for 10 volts, and as you can see at the top of the right screen, I've got the actual multimeter connected right to the output, and the electronic load right now is saying 9.96 or something like that, but I know it's a little bit inaccurate, so it is probably 9.9 or something like that. Anyway, so as you can see in the oscilloscope here, I've got no load connected right now, and there's a little bit of a ripple there, 10, 12 millivolts, but I do not have the probes to the oscilloscope that really connected in a way that is the most efficient, because I got the little ground lead, you know, connected to the probe, which will pick up a bit of noise, which may not come from the actual power supply. But anyway, so far so good. I mean, at 10 volts, 10 or 12 millivolts ripple is not a problem. Right, let me turn the load on. So it's drawing 5 amps right now, and we are getting 60 to 70 odd millivolts of ripple. And as I said, not all of that noise would be coming from the actual power supply. Now, what if I increase the voltage? Okay, 20 volts. Load on. It's drawing 100 watts. Let's reset the statistics. Still the same. I think that is pretty good. As I said, some of that noise probably doesn't come from the actual power supply because it's picking up through leads or something. .30 volts. Doesn't seem to increase it at all. Much, if any. Alright. So let's increase the amount of current. Okay, drawing 10 amps at 30 volts. I don't know, I think that that's working reasonably well. Okay, so I opened it up, and it appears that there are two exactly the same separate boards in here, and that's why it's a dual supply. They got two duplicated switch mode boards. They're exactly the same, and both of them have a connector that connects to the front panel board over here, and there's another little board over here which appears to have some chokes and things on them, I guess. And underneath there is a board with lots of large relays. And I'm wondering if I can actually hook into some of those relays and connect them to the switch up the front, so to disable them and to put a switch on the back for the power, because that would make it a lot more usable. There's also quite a few extra sockets on these boards that are empty, and this little plug here appears to be going to the 5-volt output for the USB charger, but the other board underneath has a socket like that as well, and it's not used, so presumably that could host another USB output if need be, but I don't really need that. So let me disassemble it a little bit further and see what we have. Okay, so we have this little board here that was on the top, and the power coming in, it's got N and L is supplied to it. It's got a little relay on there, and it was connected to these two plugs over here, which goes to the main board over here. I'm not sure exactly what its purpose is right now. Seems to have some opto isolator there, and anyway, let's put this aside for a sec. I'm kind of interested in this bottom board here. Has 3 really big relays on there up to 30 amps, and they're running at 12 volts DC. Somewhere this thing must be producing 12 volts to run those. Anyway, these two are outputs. Let's go channel 1, channel 2. Now the negative connections here are not connected to ground anywhere. Ground is only going to this metal board and connection here to the switch mode boards, and the two switch mode boards are completely separate and isolated from each other. That's why when you have it at independent, you have two outputs where the black sockets are not actually connected to each other, and why you have a third output. And these relays over here obviously are used in order to switch the outputs on, off, and also the series and parallel, I suspect. Got channel 1 out plus, channel 1 in, channel 2 out minus. Amazing they can sell this for under $100. So I'll put it back together. There's a bunch of probably MOSFETs that are connected to this metal here, and the metal underneath I've probably got heat sinks. Got two fans, one for each board, and the fans don't normally run, but I did when I was drawing 10 amps at 20 volts. It did start running for a short time and then it turned off again, so it's not very noisy. This is good. It's not quite as good as my other little power supply, which is also switch mode, apart judging from the little bit of noise on the output, but the thing is it's not bad. It's plenty good enough, so I think for me this will be plenty good enough. Put it next to my power supplies there, and I don't think I will need to bother buying one of those expensive linear output power supplies. I have enough capability here with these two. Then I'll be looking for a 5.5 or 6.5 digits multimeter instead that I can spend the money on. Anyway, I think that's about it to have a look at this thing, and I think I'll leave it at that, and I'll see you guys later. And don't forget to subscribe and like and all that kind of stuff. And if you have any questions, put them in the comments, and I'll see you guys later.